An American naval scout plane and dive bomber, the Douglas Dauntless SBD-6 was an essential asset to the United States Navy during World War II. Developed by the Douglas Aircraft Company, it was the final variant in the Dauntless series, featuring several enhancements over its predecessors that improved its performance and combat effectiveness. Retaining the overall dimensions of its predecessor, the SBD-5, the aircraft featured a wingspan of 41 feet 6 inches, which provided a stable platform for dive bombing operations. The overall length of the aircraft was 33 feet 1 inch, allowing for a compact yet efficient design suitable for carrier operations. 13 feet 7 inches was its height, facilitating its storage and maneuverability on aircraft carriers. The wing area measured 325 square feet, contributing to its lift and maneuverability. These dimensions were carefully designed to balance the needs for stability, control, and carrier compatibility, ensuring the aircraft could perform precise dive bombing missions effectively. Its construction involved extensive use of aluminium and steel, each chosen for their specific properties that contributed to the aircraft's performance and durability. Aluminium was extensively used in the SBD-6 Dauntless for several reasons. Its lightweight nature was crucial for maintaining the aircraft's overall weight, enhancing its maneuverability and fuel efficiency. Additionally, aluminium is corrosion resistant, a vital characteristic for naval aircraft constantly exposed to harsh marine environments. The aluminium alloy used in the SBD-6's construction provided the necessary strength without significantly adding to the weight, ensuring the aircraft could carry substantial bomb loads and withstand the stresses of dive bombing. Steel was employed in critical stress points and areas requiring additional strength, such as the landing gear and certain parts of the airframe. The landing gear needed to be particularly robust to endure the impact of carrier landings, which were often more severe than land-based operations. Steel provided the necessary durability and resilience, ensuring the aircraft could handle the repeated stresses of takeoff and landing cycles on carrier decks. Additionally, steel was used in areas of the airframe that required extra reinforcement to withstand the high G-forces encountered during steep dives and combat maneuvers. A combination of aluminium and steel in the construction of the SBD-6 Dauntless resulted in a durable and reliable aircraft capable of performing demanding dive bombing missions. The thoughtful selection of materials ensured that the aircraft could operate effectively in the challenging conditions of the Pacific theater, contributing to its reputation as a robust and dependable dive bomber. Its empty weight was approximately 6,404 pounds. This weight measurement includes the aircraft's structure, engine, avionics, and all necessary equipment, but excludes fuel, bombs, ammunition, and crew. The relatively low empty weight was achieved through the extensive use of lightweight materials such as aluminium. This base weight was crucial for maintaining the high level of maneuverability and ensuring that the aircraft could take off from and land on aircraft carriers, which have limited runway space compared to land-based airfields. 10,700 pounds was its maximum takeoff weight, or MTOW. This figure represented the total weight of the aircraft when fully loaded with fuel, bombs, ammunition, and crew members. The difference between the empty weight and the maximum takeoff weight, approximately 4,296 pounds, indicates the payload capacity that the SBD-6 could carry, including offensive and defensive armaments, fuel for extended range missions, and other mission-critical equipment. Achieving this MTOW required careful balancing of engineering to ensure that the aircraft could still perform optimally under the stress of full loads. The robust construction, featuring a combination of aluminium and steel, enabled it to handle the increased weight without compromising its structural integrity or flight performance. The aircraft's powerful Wright R1820-66 Cyclone engine, producing around 1,350 horsepower, was capable of delivering the necessary thrust to lift the fully loaded aircraft off carrier decks and sustain it through combat missions. The aircraft's ability to carry a substantial payload meant it could deliver powerful strikes against enemy targets. The bomb load, combined with its machine gun armament, allowed the Dauntless to engage effectively in both offensive bombing runs and defensive engagements against enemy aircraft. Additionally, the weight distribution and design facilitated the aircraft's dive bombing capabilities, allowing for steep, controlled dives crucial for precision bombing. Several unique design features distinguished it from other bombers. These features were integral to its performance, durability, and operational versatility. One of the most innovative and distinctive features was its perforated dive brakes. Located on the wings, these dive brakes were crucial for executing steep, controlled dives, which were essential for precision bombing. Perforations in the dive brakes increased drag without significantly compromising stability, allowing pilots to maintain control of the aircraft during high-speed descents. This design enabled the Dauntless to achieve a near vertical dive angle, reducing the target's opportunity to evade and ensure a higher probability of hitting the intended target. An ability to control descent speed and maintain stability during dives made the SBD-6 exceptionally effective in its role as a dive bomber. Being a low-wing monoplane, this configuration offered several benefits in terms of stability and handling. The low-wing design provided a stable platform which was essential for the precise control required during dive bombing runs. This design also improved visibility for the pilot, an important factor during both navigation and combat operations. The monoplane configuration, characterized by a single set of wings attached to the bottom of the fuselage, contributed to the aircraft's aerodynamic efficiency, enhancing its maneuverability and speed. A combination of stability and responsive handling allowed the Dauntless to perform complex maneuvers, making it a versatile aircraft capable of adapting to various combat scenarios. Engine and performance. Its performance was significantly influenced by its power plant and aerodynamic design. Key to this performance was the Wright R1820 Cyclone engine, a reliable and powerful radial engine that drove the aircraft's impressive capabilities. Powered by the Wright R1820-66 Cyclone engine, this 9-cylinder air-cooled radial engine was a crucial component in providing the necessary power and reliability for the aircraft's operations. The R1820-66 Cyclone engine produced approximately 1,350 horsepower, a significant upgrade from earlier models. The engine's robust design and air cooling system reduced the need for complex liquid cooling mechanisms, thereby enhancing reliability and simplifying maintenance. The air-cooled configuration was particularly advantageous in the Pacific theater, where engine overheating could be a crucial issue. The Wright R-1820-66 Cyclone engine endowed the SBD-6 Dauntless with a range of performance characteristics that made it an effective combat aircraft. These included its speed, climbing rate, service ceiling, and operational range. This aircraft had a maximum speed of about 255 miles per hour, 410 kilometers per hour. This speed enabled it to engage effectively in dive bombing missions and evade enemy fighters when necessary. The cruising speed of the aircraft was around 185 miles per hour, 298 kilometers per hour, allowing for efficient long-range operations without excessive fuel consumption. Able to climb to 10,000 feet, 3,050 meters, in just over 7 minutes, this climb rate facilitated rapid ascents during combat, enabling the aircraft to quickly reach optimal dive bombing altitudes or evade ground-based anti-aircraft fire. A service ceiling of the SBD-6 Dauntless was approximately 25,530 feet, 7,780 meters. This high-altitude capability allowed the aircraft to perform reconnaissance missions and operate above the effective range of many anti-aircraft defenses. The ability to reach and sustain high altitudes was important for the strategic flexibility it provided in both offensive and defensive operations. Its operational range was somewhere around 1,115 miles, 1,795 kilometers, when carrying a standard bomb load. This range could be extended with the use of auxiliary fuel tanks, which allowed the aircraft to undertake long-range missions critical in the vast expanses of the Pacific theater. Extended range capabilities enabled the Dauntless to strike targets far from its carrier bases, providing strategic reach that was essential for island-hopping campaigns and deep strikes into enemy-held territory. A comprehensive array of armaments made it a formidable dive bomber and effective in its role as a versatile combat aircraft. These armaments included strategically placed machine guns, substantial bomb load capacities, and innovative bomb release mechanisms that enhanced its offensive capabilities. The SBD-6 was armed with multiple machine guns to provide both offensive and defensive firepower. The aircraft was equipped with 2 forward-firing Browning M2 50 caliber machine guns mounted in the engine cowling. These machine guns were synchronized to fire through the propeller arc. Each 50 caliber machine gun was capable of firing at a rate of 800 rounds per minute, providing significant firepower against enemy aircraft and ground targets during strafing runs. A rear cockpit housed a flexible mount with twin 30 caliber machine guns. Operated by the rear gunner, these machine guns provided a defensive capability against attacking enemy aircraft. The gunner's position was designed for maximum effectiveness, allowing for a wide range of motion to engage targets from various angles. The 30 caliber machine guns fired at a rate of 1,200 rounds per minute, offering a robust defense against enemy fighters. Primarily designed as a dive bomber, it had to be capable of delivering a substantial payload with precision. The aircraft could carry a single 1,000-pound bomb or a 500-pound bomb on the centerline bomb rack located under the fuselage. This bomb rack was the mainstay of the Dauntless's offensive capabilities, allowing it to deliver a powerful payload against enemy ships, fortifications, and other strategic targets. In addition to the centerline bomb, it was equipped with 2 wing racks, each capable of carrying a 100-pound bomb. These smaller bombs complemented the primary bomb load, enabling the aircraft to attack multiple targets or deliver a more substantial overall payload. One of the key innovations of the SBD-6 Dauntless was its bomb release mechanism, which was designed to ensure accuracy and safety during dive bombing operations. A centerline bomb rack featured a trapeze mechanism that swung the bomb clear of the propeller arc before release. This innovative design prevented the bomb from striking the propeller during steep dives, ensuring safe and accurate bomb deployment. The trapeze mechanism allowed the bomb to fall directly along the aircraft's dive path, enhancing the precision of the strike. Perforated dive brakes on the wings allowed for controlled, steep dives by increasing drag and stabilizing the descent. This capability was crucial for maintaining accuracy during bomb release. A Mark 8 telescopic bomb sight provided the pilot with a clear view and precise aiming reticle during dives. This sighting equipment was instrumental in aligning the aircraft with the target, ensuring that bombs were dropped accurately. Both pilot and rear gunner had distinct responsibilities and required specialized training to maximize the aircraft's effectiveness in combat. The pilot held a multifaceted role that required a high level of skill and coordination, responsible for the overall control and navigation of the aircraft. This included managing takeoffs, landings, and flight maneuvers. One of the pilot's most crucial tasks was executing dive bombing runs. This involved positioning the aircraft at the correct altitude and angle for a dive, deploying the dive brakes, aiming at the target using the bomb sight, and releasing the bomb with precision. He maintained radio communication with the carrier, other aircraft, and ground forces. Effective communication was crucial for coordinating attacks and receiving instructions. The pilot began a dive bombing run from a high altitude, typically between 10,000 to 15,000 feet. Upon identifying the target, he would enter a steep dive, using the perforated dive brakes to control the descent speed. The Mark 8 bomb sight was used to line up the target, ensuring accurate bomb release. A rear gunner, also known as the radio man or observer, played a crucial defensive and support role. He operated the twin 30 caliber machine guns mounted on a flexible ring. These guns were used to defend the aircraft from enemy fighters approaching from behind. As the radio man, the rear gunner was responsible for maintaining communication with other aircraft and the carrier. This involved sending and receiving messages, as well as reporting enemy sightings and damage. Training in radio operations was essential. The rear gunner had to be adept at using the aircraft's communication system to relay important information efficiently and clearly, ensuring that the pilot was aware of any threats or instructions. In the event of aircraft damage, the rear gunner assisted with in-flight damage control, such as dealing with minor fires or system malfunctions. This role required a solid understanding of the aircraft systems and emergency procedures. Training and techniques for dive bombing and aerial combat. Pilots were trained to approach targets at high altitudes and initiate steep dives, controlling descent with precision using the dive brakes. The accuracy of bomb release was emphasized, with practice runs conducted to ensure proficiency. Both crew members received training in aerial combat techniques. Pilots learned evasive techniques to dodge enemy fire and position the aircraft advantageously. Rear gunners practiced targeting and firing at enemy aircraft, developing quick reflexes and accuracy. Effective teamwork between the pilot and the gunner was crucial. Training included coordinated drills to ensure seamless communication and cooperation during combat scenarios. This teamwork extended to maintaining situational awareness and responding rapidly to threats. Effective communication was vital. The aircraft was equipped with advanced radio and intercom systems that facilitated coordination between the pilot and the rear gunner, as well as with other aircraft and command units. The primary communication device was the SCR-535 radio. This system was essential for maintaining contact with the aircraft carrier, other aircraft in the formation, and ground control units. The radio allowed the pilot and gunner to receive mission updates, relay reconnaissance information, and coordinate attack strategies. Its SCR-353 operated across multiple frequencies, ensuring reliable communication even in the complex and varied electromagnetic environments of the Pacific Theater. In addition to voice communication, the radio system could also be used to send Morse code messages, providing a backup communication method in case of voice transmission issues. The pilot and rear gunner used an intercom system to coordinate their actions during flight. This internal communication was crucial for maintaining situational awareness and executing complex maneuvers. The intercom allowed the pilot and gunner to communicate directly, sharing immediate tactical information and coordinating responses to threats. Designed to function effectively in the noisy environment of an active combat aircraft, the intercom system included noise-cancelling features to ensure that communication remained clear. Pilots typically began their dive bombing runs from high altitudes, around 10,000 to 15,000 feet, to gain sufficient altitude for a steep dive and to reduce the chances of being intercepted by enemy fighters. Using the Mark 8 telescopic bomb sight, pilots could accurately line up their targets during the dive. This sighting system was crucial for ensuring precision strikes, especially on moving targets such as ships. The trapeze bomb release mechanism allowed bombs to swing clear of the propeller arc before release, ensuring safety and accuracy. Pilots released bombs at altitudes as low as 1,500 feet, pulling out of the dive just above the ground or sea level. Flak avoidance maneuvers. Zigzag approach. To avoid anti-aircraft fire, flak, pilots often approach their targets in a zigzag pattern, making it difficult for enemy gunners to predict their path. Rapid descent and ascent. During the dive, the aircraft's speed increased, making it a challenging target for anti-aircraft guns. After releasing the bomb, pilots would perform a rapid pull-out maneuver to climb back to a safer altitude as quickly as possible. Defensive jinking. While climbing or evading, pilots employed jinking maneuvers, sharp, unpredictable changes in direction to throw off enemy aim. Defensive tactics. Gunner coordination. A rear gunner played a crucial role in defending the aircraft against enemy fighters. Using twin 30 caliber machine guns, the gunner provided a defensive shield, deterring or damaging attackers approaching from the rear. Evasive maneuvers. In the event of an attack, the pilot and rear gunner coordinated closely to perform evasive maneuvers. These included sharp turns, rolls, and dives to shake off enemy fighters, while the gunner engaged them with defensive fire. Damage control. The rear gunner was also responsible for reporting any damage sustained during combat, allowing the pilot to make informed decisions about continuing the mission or returning to base for repairs. One of its significant missions was during the Battle of the Philippine Sea in June 1944. SBD-6 Dauntless dive bombers played a decisive role in the battle, contributing to the destruction of Japanese aircraft and carriers, thus securing a decisive victory known as the Great Marianas Turkey Shoot. Another significant engagement was the Battle of Leyte Gulf in October 1944. The SBD-6 participated in this largest naval battle of World War II, attacking Japanese surface ships and providing crucial close air support during the invasion of Leyte. Operation Hailstone in February 1944 also highlighted the versatility and endurance of the SBD-6 Dauntless. During this major raid on the Japanese naval base at Truk Lagoon, SBD-6 dive bombers effectively destroyed a large portion of the Japanese fleet and support vessels, significantly weakening Japan's naval capabilities in the Central Pacific. If you enjoyed this video, be sure to check out our other content related to aviation history and World War II.